let's solve part B now. So we have the integral of this expression. Now I wrote it over here below so we can work with it. What do we have here? We have an addition of two terms to the power of 2. Now because we have powers here and we use the integral, then it would be wise to use the power rule of integration like we did in the previous video with that property over here. But we don't just have the terms to the power, we have an expression to the power of 2. A wise thing to do would be to expand this expression, because then we would have separate terms. So let's see how that would work out. We would have the integral of the following. This is the same as saying a plus b to the power of 2. These are just two terms. So we know the property of a plus b to the power of 2. That's a squared plus 2ab plus b squared. So let's do that. That would be the first term to the power of 2. So we have x to the power of 4 to the power of 2. Let me just keep the brackets over here. Plus 2 multiplied with the first term, which is x to the power of 4, and multiplied with the second term, which is 2x cubed. So times 2x cubed. And then we do that also for b squared. So plus the second term, which is 2x cubed, all of it to the power of 2. So all of it to the power of 2. We close the brackets, times dx, right? We're still integrating. So times dx, we have here dx. Okay, let's keep solving. What do we have as a result? We write it over here below. X to the power of 4 to the power of 2. Well, we have x to 2 powers, so we multiply the powers. That's 4 times 2, and that's just going to be 8, plus 2 times 2, we have 2 times 2, that's the constants, is going to be 4, so we have a 4, times x to the power of 4 times x to the power of 3. We multiply 2 powers with the same basis, but we have, or 2 exponents, I don't know actually how to call them correctly. I think it's 2 exponents with the same basis, x and x, but then we have to add the powers, 4 and 3. So it's x to the power of 4 plus 3, which is equal to 7. And then we also raise to the power of 2 the next term. So plus 2 to the power of 2, that's 4, times x to the power of 3 to the power of 2. Well, that's just x to the power of 3 times 2, which is 6. Now, we close the brackets over here. All of it dx. Okay, what can we do now? We can use our, sorry about that, we can use our power rule for integration. We can use our power rule for integration, right? The one we used in the previous video. So let's do it for every term, because now we finally have an expression, a sum of 3 terms where we have powers. So it's gonna work. We will have the following. We will have the integral of x to the power of 8. What is the integral of x to the power of 8? That's x to the power of 8 plus 1, which is 9, divided by 8 plus 1, which is also 9. Plus, we go to the next term, the integral of 4 times x to the power of 7. Well, we can keep the constant. That's going to be 4 multiplied with x to the power of 7 under the integral. That will be x to the power of 7 plus 1, x to the power of 8, divided by 7 plus 1, which is also 8. All right. And by the way, why am I still writing the integral? We're already integrating, so that's the result. Sorry about that. We should take this out. This goes out, and this goes out as well. Plus, what do we have next? We have 4 multiplied with the integral of x to the power of 6. That's x to the power of 6 plus 1, which is 7, divided by 6 plus 1, which is also 7. And then finally, we add a constant. So plus c, plus a constant. Okay, what do? We can cancel out some terms over here, because 4 and 8 cancel out, and we're left with 2. So as a result, we're going to have x to the power of 9 over 9, x to the power of 9 over 9, plus x to the power of 8 divided by 2, x to the power of 8 divided by 2, and then finally plus 4x to the power of 7, 4x to the power of 7 divided by 7 plus a constant. So plus a constant over here, and that would be the answer, and we are done.